Okay, friends, we are back. We are going to find, adjust that light a little bit, finding area of non-rectangular shapes. This is where my fun part comes in. I am on page 300, and again, I know you can't see everything the right way necessarily. Please remember that you have this in your book, so look in your book. Okay. Oh, read the problems below, then explore different ways to find the area of shapes that are not rectangles. So, Alexis, you're popular today. Alexis used 1-inch square tiles to build the shape shown on the right. What is the area of Alexis's shape? And this is where you can't do length times width equals area the way we have been doing it, because these are not complete rectangles. Picture it. You can find the area of the shape by counting the number of square units that cover the shape. And I've seen you count before. You can definitely count to 10. So that would be 10 square units. Each square unit has an area of 1 square inch. Sorry, I've got some papers everywhere. Let's see if I can zoom that there, maybe. Ooh, it's like at school, kids. There we go. That's a little better. You can find the area of a shape by breaking it apart into smaller shapes. One way, you can break Alexis's shape into 2 smaller shapes like this. So you see how this represents that part, and then the little 2 of them over there, right there. Area of 8 square inches, area of 2 inches, and then add those together. Dun, dun. Another way, you can break Alexis's shape up into 2 different smaller shapes like this. So do you see where they took this part and this part? So it really doesn't matter how you break it up, as long as you break it up. So let's take a look on the next page, 301. Connect it. Solve the problem from the previous page using multiplication and addition. Model it shows 2 ways to break apart Alexis's shape. Look at the first way. For each smaller shape, write a multiplication equation to show its area. So let's take a look here. We've got 1, 2, 3, 4, and 1, 2. So length times width. 2 times 4. We're supposed to write it here, aren't we? 2 times 4 equals 8. And then we're going to take our smaller shape, which is 1 and 2. 1 times 2. Bring that there. Over to this side. 1 times 2 equals 2. Write the addition equation to show the total area of Alexis's shape. So we've got 8 and we've got 2. 8 plus 2 equals 10. The total area of Alexis's shape is 10 square inches. Look at the second way to break apart Alexis's shape. For each smaller shape, write the multiplication equation to show the area. So let's take a look. What's the length? 1, 2, 3. You cannot see that very well, can you? Let's see. The way the camera is, it makes it look like my numbers are really stretched out there. Let's see. Ooh, you getting dizzy yet? See how that goes. Okay. Well, they look like they're stretched out. They're not that stretched out. So we've got 3 for the length, and then the width is 2. So that's 3 times 2, which equals 6. I don't want to really zoom the right way. But again, you can see this in your book. Yikes, I think that made it worse. Oh, goodness. We're having troubles today, aren't we? Okay. And then this shape, which is the length is 2, the width is 2, 2 times 2 equals 4. 6 plus 4 equals 10. The total area of Alexis's shape is 10 square inches. How does this total compare to the total area you found in problem 9? They are the same. Mike, no. Valentina breaks apart the shape into 2 smaller shapes. Sunny breaks the same shape apart into 2 different shapes. Explain how you know that the total of Mike's 2 shapes is the same as the total of Rick's 2 shapes. The square units don't change. Let's just say the total square units to be more clear. Total square units don't change. That's how you know it will be the same answer. It doesn't matter how you split it up, as long as you are using all of the squares. So this, I love how this is the part I love. So use what you just learned about adding area to solve these problems. Show your work on a separate sheet of paper. We're just going to use the space we have around us here. Seeing if you can see it. So what is the total area of this shape below? You might look at this and think, what? How am I going to figure that out? Well, you are. It's not as hard as it looks. We get to decide how we want to split this shape. So there are 2 ways you could split it. We need it to be in rectangles. So you could split it this way, do a little line there, or you could split it this way and have a line there. I think I am going to choose to split mine this way. So now I have 2 different rectangles. I'm going to find the total area of each rectangle. So length of this one and width of this one. Length times width, 9 times 10 is 90 square meters. And here it says the length of this, see this little arrow that points there? It says that's 5. And then the width is 4. 5 times 4, which is 20 square meters. I know that's hard to see. So now we're going to add 90 plus 20. So we add 2 10s. So you could either do that in your head and say 90, 100, 110. If you need to see that written out, it looks just like this. 0 and 0 is 0. 9 plus 2 is 10. 100 square meters. Okay, let's see if we can figure out how to do the next one. We can split this rectangle 2 ways, or this shape 2 ways, and make 2 rectangles. You could split it this way, or you could split it this way. I'm going to split it this way. And either way you split it, you'll still get the same answer. So there's any way you want to split it. So let's find the area of this rectangle first. My length is 8. My width, it's not 5, because that is this whole area, and I'm just finding this area. So I need to use the 3. 8 times 3, 8, 16, and 24 square centimeters. And then let's find this one. So the length, it's not 8, it's 7. See the difference there? We're finding this rectangle. So 7, and again, it's not 5, okay? It's 2, because it's these are our lengths and widths. So 7 times 2, 714, there you go, centimeters. So let's add 14, and 24. If you need to see that written out, it looks like this. 4 and 4 is 8. 2 and 1, 3. 38 square centimeters. And I encourage you with things like this to stop the video and see if you can figure that out on your own. Okay, guided practice. We're in it now, friends. Study the example below, then solve problems 14 through 16. And I think I'll break this up into guided practice versus modeled guided instruction. So I'm going to stop the video right there, and I'll do another video.